In this video, I'm going to solve this limit where we know a is a real number. Okay, to solve this question, we need an algebraic identity. First, we write this identity because we're going to use it several times in solution of this limit. The formula is x to the power of n minus a to the power of n is equal to x minus a times x to the power of n minus 1 plus a x to the power of n minus 2 plus and so on. We keep writing until we have a and minus 3x squared plus a and minus 2 and x, and the last term will be a to the power of n minus 1. So in each of these terms, you can see the summation of powers of x and a is n minus 1. So here is like a, the power of a is 1 and the power of x is n minus 2. The summation is n minus 1. So always for each of the terms in this identity, the summation of exponents of x and a will be n minus 1. Since we're going to use it several times, I just want to have a name for this part. I'm going to call it Q and A at x. I give a name to this part, so because of this new notation, we're going to have x to the power of n minus a to the power of n is x minus a q n a x. Okay. Let's keep this identity here. So the limit is, now let's simplify the limit using this identity. So it's going to be limit of the numerator xn minus an using the identity will be x minus a times qan x, then it's minus n a to the power of n minus 1 x minus a divided by x minus a squared when x approaches a. Now here from numerator we can factorize x minus a and cancel by 1 x minus a from denominator, so then let's write it. So it's x minus a times q and a x minus n a n minus 1 divided by x minus a squared when x approaches a. So now we can cancel x minus a by one of the x minus a's in denominator. So this limit is going to be equal limit of, now in numerator we're going to have, we expand q and a x by its actual expression and we write x to the power of n minus 1 plus x to the power of n minus 2a plus x to the power of 2a n minus 3 plus x a n minus 2, and the last term is going to be an minus 1, and then minus n a to the power of n minus 1 divided by x minus a when x approaches a. For the next step, so here what we have is n a to the power of n minus 1. That means we have a to the power of n minus 1 added by itself n times. So it's like a n minus 1 plus a n minus 1 a n minus 1, and it's n times. And from the first part we have 1, 2, and n term here. So you can see, if you just count it, you can see there are n terms in the first parenthesis. So we have n terms here, x to the power of n minus 1, x to the power of n minus 2a, until a to the power of n minus 1. So it is n terms here, and there are n terms of a to the power of n minus 1. So we rewrite the numerator again in this new form. We say it is equal to limit of it's x to the power of n minus 1 minus a to the power of n minus 1 plus, now the second terms, which is x to the power of n minus 2a, now again minus a to the power of n minus 1 plus, let's write the last terms. It's going to be x squared a to the power of n minus 3 minus a to the power of n minus 1 plus x a to the power of n minus 2 minus a to the power of n minus 1, and the last term will be cancel a to the power of n minus 1 minus a to the power of n minus 1, which is 0. We don't need to write it, and denominator is going to be x minus a again when x approaches a. Okay, so now let's simplify this one. It is limit of, just let's keep the first term so far. This from the second term here we can factorize a, so it's going to be plus a times x to the power of n minus 2 minus a to the power of n minus 2 plus, what about the other term here? We can factorize a to the power of n minus 3, so it is plus a to the power of n minus 3, and we're going to have x squared minus a squared, and the last term of the numerator, if you factorize a to the power of n minus 2, so it's going to be a to the power of n minus 2 times x minus a. Okay, and denominator is x minus a when x approaches a. Now let's back to the identity we have. So you can see we have some terms. The first one is x to the power of n minus 1 minus a to the power of n minus 1. Here, the second term includes x to the power of n minus 2 minus a to the power of n minus 2, and you can see it's x squared minus a squared, x minus a. So we need to use the identity we had here, this one in the red box, but each time for different values of n. So here we have the formula for n, so we need to use it for n minus 1, for n minus 2, to 2, and 1. Okay, for n times, to rewrite each of these terms using that identity. So this limit, if we rewrite it again, is going to be, the first term is, using the identity, is x minus a times q n minus 1 ax. So what about the second? It's plus a x minus a q n minus 2 a at x plus a to the power of n minus 3, and it is x minus 1 times x plus 1, and keep the last term is just a to the power of n minus 2 times x minus 8. So you can see we can factorize from the numerator x minus a and cancel it with x minus a in denominator. So let's factorize x minus a from the numerator. So it's limit of x minus a qa n minus 1 at x plus a q n minus 2a x plus a to the power of n minus 3 x plus 1 and plus a to the power of n minus 2 x minus a. Okay, not bad. So here it's not x minus 1, it's x minus a, x plus a. So I just rewrite it again, x minus a, and a here. Okay. And also here it's not 1, it's a, so x plus a divided by x minus a when x approaches a. Okay. So now you can cancel x minus a by x minus a from the denominator, and this limit is just we need to simply plug in x equal a into the numerator. So the limit is going to be q n minus 1a at a plus a q n minus 2a at a plus a to the power of n minus 3 and 2x 2a plus a to the power of n minus 2. So to simplify this one, we need to talk about the value of qna at a. So let's back to the formula. For qna at x, you can see qna, the value at a is going to be, if you just plug in a into the formula of q and a, so you can see it is a to the power of n minus 1 plus a to the power of n minus 1 plus again a to the power of n minus 1 plus a to the power of n minus 1. How many times? So if you just check, it is n times, so it's going to be equal n a to the power of n minus 1. So q and a, its value at a is going to be n a to the power of n minus 1. Okay, so let's back to the formula. So it is, so the first one, it's n minus 1 a to the power of n minus 2 plus the second one is a to the power of n minus 3 times n minus 2 plus, and the last one is going to be 2a to the power of n minus 2 and plus a to the power of n minus 2. So if you just simplify, it's going to be n minus 1 a to the power of n minus 2 plus n minus 2 a to the power of n minus 2, 2a n minus 2 plus a n minus 2. We can factorize a to the power of n minus 2. It's a to the power of n minus 2 multiplied by n minus 1 plus n minus 2 plus 2 plus 1, and it is a n minus 2 multiplied by n minus 1 times n divided by 2. And it is a solution, which you can see the answer is based on A and